Okay, so today's learning goal, I haven't written it down here, is going to be simplifying expressions. So we're going to do a quick review of some of the main concepts from this tricky subject of algebra and exponents. So you have all of the exponent rules in front of you. This is a really good piece of paper or page to have in front of you at all times when you're doing these types of problems. I would like to point out one major piece right here. Right here. These rules require multiplication, division, or more powers, not adding or subtracting. And it's these rules that change exponents. Okay, so that's really important to understand that it's the exponent rules that change exponents, and they only happen when we are multiplying, dividing, or working with other powers. Okay, that's a big, big concept. Okay, collecting like terms, you have to have the exact same variable combination after the coefficient. So when you have something like this, 5a squared, this is the coefficient, this is the variable, and if you want to have a like term, okay, that's going to be similar to it, something like 6a squared, everything after the coefficient has to be exactly the same. So if you look at the examples here, everything after the number is the same. 6xy, 3xy, 3yz. These are exactly the same because the order of multiplication doesn't matter, so you can reverse the x and the y. 2x squared y cubed and 3x squared y cubed. You'll notice those values after the coefficient are exactly the same. Okay, down here, not the same. This one has an extra a squared. This one has an extra x squared. And then this one has the exponents reversed. So those are not like terms. Okay, and collecting like terms requires adding or subtracting. So you'll notice there's two bunches of information. Collecting like terms applies to adding, subtracting. Exponent rules applies to multiplication, division. Okay, and so what we're going to do today is we're actually going to mix them together, and then we're going to have to make some decisions. Okay, so let's start with collecting like terms. We'll just do a quick warm-up. Okay, so we have 5a plus 9b minus 4a minus 12b. So the only terms that are like are these guys right here and these guys right here. So the a's and the b's are going to play with each other. So 5a minus 4a is 1a. 9b minus 12b is negative 3b. Okay, we'll come down here. We have a 4x squared and a 2x squared, so those can combine for 6x squared. We have a 6x and an 8x, that gives me 14x, and we have negative 7 minus 9, that's negative 16. Okay, and the one thing I'd really like to highlight here, no exponents changed. Okay, because we're only adding and subtracting, none of the exponents were changing. It's only when we use our exponent rules do the exponents change. Okay, so distributive property. So we found a shortcut where we can multiply that 2 into both. In this question, we'd have 2x plus 10. Okay, now here we have the same idea. We're going to multiply that 3x into both terms. Please note, though, we're going to have 3x times 2x, and then a 3x times a 4. And now because this is multiplication, and this is really key, because this is multiplication and we have to use some exponent rules here, because remember there's little ones on these x's, the exponents are going to change. So the first term would become 6x squared. The second term would become just 12x. There's no x's to interact with that x, so it just stays the same. And then lastly, if we distribute this guy here, I'm going to change colors because it's going to get a little busy. We would have negative 15x cubed. If you have to, you can put a placeholder on that x, plus 5x squared. Okay, and I'd like to point out, get rid of this screen here. Oops. Oh my goodness. Come on, tools. There we are. Notice the exponents change because we're multiplying. Okay. All right. So distributive property when we're doing two binomials multiplied together. Okay, we talked about different ways of setting this up. I personally really like the area model. So something like this helps keep track of all of the terms. If you want to do FOIL, we can also do FOIL. FOIL was the arrows like this. Okay, I like the area model. X times x is x squared, and again we're multiplying, so the exponents can change. Here's a 4x, a 1x, oops, and then a plus 4. I shouldn't write the plus in there just yet. Let's get rid of that guy. And then let's bring it all together. So we would have, whoa, that's a line out of nowhere. All right, let's try that again. So now we have x squared. These two guys can combine. They're like terms, so if we wanted to, we could rewrite this a little bit more. 4x plus 1x plus 4, and this would become x squared plus 5x plus 4. So we did a little bit of collecting like terms, we did a little bit of exponent rules, so we have questions that mix both problems up. Okay, let's see if we can make this page a little longer. I'm going to move to green. Alright, so again, I'm going to do my area model, 2x, and then a negative 5, 3x, and a negative 1, multiply together, so I expect some exponents might change. And there's the first one that did. There's no x's in that second term. Multiplying through, and then this is a positive 5. So when we bring that all together, we would have 6x squared. These two terms here we could collect together, minus 17x plus 5, and there would be the answer. Okay, so that was a little bit of an intro of mixing it all up. So now we're going to do about 3 or 4 where we mix them all up completely. Okay, so this says expand, which means multiply. Simplify means collect like terms and bring it all together. Okay, so I'm going to do distributive property. Okay, I can't touch any of these adding, subtracting terms inside the bracket, okay, until I deal with that multiplication out front. That's really, really important. Okay, so these guys I'm going to distribute out. I get my 2x plus 6 plus 4x minus 20, and now I have to just collect like terms, so I have a 2x and a 4x. There's my 6x, 6 and negative 20. There's negative 14. Okay, and don't be afraid to underline things, highlight things that are of like terms. It's good practice. Okay, so this one, we got to really be careful with this one. Okay, so as we multiply in, we have x's being multiplied together, so we would expect some exponents to change. I'm going to multiply this whole second bracket by negative 3x. That's going to remove me having to think about the subtraction as a separate entity. So I'm going to do this as 2x squared minus 2x. So take a second and look at that, because the 2x times an x is going to change. That's multiplication of x's, so we add the exponents. And then I have negative 3x squared plus 6x. So that's where our exponent rules come in, because we were doing multiplication. Now we're shifting to collecting like terms. So now my exponents will not change because I'm only adding and subtracting. So a 2x minus a 3x is negative 1x squared, and a negative 2x plus 6x is a positive 4x. Okay, so you'll notice none of the exponents change on that line. So there's two separate thoughts you have to have there. Very important. Okay, this is a big scary one. It looks really nasty. If you have to, take several lines. You can try it if you like, so just pause the video. Okay, so I'm going to carry on here, and I'm going to take my time. Okay, so there's the first multiplication, there's the second multiplication, and if you have to, include an extra line. That's totally fine. So there's my first term. There's my second term. Okay, and then I'm going to switch colors. And then I'm going to do 4x times x squared and 4x, oops, forgot my bracket, times negative 7x. Okay, so if I count them up, I should get 2 terms from the first set here, 2 terms from here, and another 2 terms from here for a total of 4 terms. And if I count, I have 4 sort of blocks of terms. So what I mean by that is this is 1, 2, 3, 4, so I've got everything accounted for. And now I just have to do the actual calculations. So negative 3x squared times x squared would become negative 3x to the fourth. The next one would be negative 18x cubed plus 4x cubed. Cubed is 3, just in case we haven't said that. 28x squared. Okay, now I take a look to see, is there anything that's a like term? And we should see these two here are like terms. So we would finish with negative 3x to the fourth minus 14x cubed minus 28x squared. Okay, and again, when I'm collecting like terms, the exponents don't change. It's only when we multiply. Okay, so let's put it into some context. Find the expression for both the perimeter and the area. So a reminder, perimeter is the distance around the outside. Okay, that's what perimeter is. So now I find when I have these types of questions, it's very, very handy to write in the missing dimensions so you don't forget things. So a single tick means these are the same. So this is a 3x. And a double tick means these are the same. So this is a 5x minus 4. So if I want the perimeter, there's lots of ways to write this, but I'm just going to do it the easiest way that I normally see. We have a 3x plus a 5x minus 4 plus a 3x plus a 5x minus 4. So those are the four sides. If I started at this corner and I went all the way around this shape, those are the four sides all added together. And then I would get perimeter. Now I just have to collect like terms. I'm adding here, so my exponents are not going to change. So 3x plus 5x is 8x, plus another 3 and 5 gives me 16 x's altogether, and then minus 8. So this is an expression for my perimeter. You can't get a number answer unless you're given more information. Okay, so now we want to also find the area. So I'll do area in purple. Area, as we've done with our other area models, is length times width, base times height, whatever you want to call it. Okay, those two dimensions. So it's going to be these two dimensions multiplied together. So area would be 3x times 5x minus 4. Okay, now this is a distributive property, so I'm going to multiply this in, and again I'm going to come up with an expression. I won't get an actual number answer, I'll just get an expression for the area. And because it's multiplying, I'm expecting that exponents might change. So I would have 15x squared minus 12x. Okay, now neither one of these you can come up with something unless you're given more information. So I'm going to give you a little bit more information. What is the value of x when the perimeter is 56? Okay, so now we have to do a little thinking here. If we looked at this expression right here, there are two unknowns. There's a p and there's an x. I am being told that the perimeter is 56 centimeters. So if I want to make a substitution of that 56 centimeters, should it go in for p or should it go in for x? And you are correct. The answer is p. This is a perimeter value, so it should go into the perimeter location in my equation. So I have this expression right here. I'm told the perimeter is 56, so I replace it. And now I have to solve this equation like we've already done. Okay, so I'm going to add 8 to both sides. Those would cancel. So now I have 64 equals 16x. I then divide both sides by 16. And I end up with x equals 4 centimeters. Okay, now if I was asked also what are the dimensions of this problem, I could take my x equals 4 centimeters and I could substitute it back into the original values on the diagram. So this would become 12 centimeters. This would be 12 centimeters, just 3 times 4. This would become 20 minus 4, this would be 16 centimeters. And this would be 16 centimeters. And if you add up those four values, you should get the 56 centimeters that you were told is the perimeter. Okay, a couple questions to try. Thank you for tuning in. Much appreciated.